Think about the last time you saw a cartoon mouse. What was it eating? Probably a yellow wedge of cheese with giant, perfect holes in it. It is the universal symbol for cheese. But here is the weird part. For almost a century, the smartest food scientists on the planet could not agree on why those holes exist. And then, around 15 years ago, the holes started to disappear. Farmers were panicking, scientists were baffled, and the secret they eventually uncovered involved something so simple, so gross, and so unexpected that it changed the way we look at dairy forever. If you go to a grocery store in the United States and ask for Swiss cheese, you are usually getting a mild, nutty cheese that is famous for its eyes. That is what the industry actually calls those holes. In the rest of the world, this is known as Emmental cheese, named after the Emme River Valley in Switzerland, where it has been produced since the 1200s. For hundreds of years, making this cheese was like magic. You take milk, you do the traditional cheese-making steps, and then you put the giant 200-pound wheels into a warm cellar for a few weeks. Like clockwork, the cheese would start to swell. The flat sides would bulge out like a balloon. When you finally cut it open, it was full of those iconic, smooth, round cavities.
For a long time, people had some pretty wild theories about where these holes came from. Some thought they were caused by tiny spirits. Others thought the cheese was just rotting in a very specific, delicious way. But as science progressed in the late 1800s and early 1900s, we thought we finally cracked the code. The credit was given to a very specific type of bacteria called Propionibacterium frudenreichi. That is a massive name for a tiny organism, so let us just call it the P bacteria. Here is how the textbook explanation went for over 100 years. To make Swiss cheese, you add 3 types of bacteria to the milk. The first 2 turn the milk sugar into lactic acid, but the third one, our P bacteria, is the star of the show. It actually eats the lactic acid produced by the other bacteria. As it digests that acid, it releases carbon dioxide gas. In most cheeses, gas just leaks out of the curd, but Swiss cheese has a very specific elastic texture. As the P bacteria burps out CO2, the gas gets trapped inside the solid block of cheese. It forms a tiny bubble, and as more gas is produced, that bubble grows and grows, pushing the cheese aside to create a perfect, smooth sphere. It was a perfect explanation. It was elegant, it was scientific, and for a long time, everyone accepted it as fact. But then, something strange happened. In the mid-1990s and early 2000s, the holes in Swiss cheese started to shrink. In some batches, they vanished completely. This might not sound like a big deal, but for the Swiss dairy industry, it was a total catastrophe. You see, the size and distribution of the holes determine the grade of the cheese. If the holes are too small, or if there are no holes at all, the cheese is called blind. Blind cheese is considered lower quality and sells for a much lower price. The cheesemakers were doing everything exactly the same way their grandfathers did. They were using the same milk, they were using the same P bacteria cultures, they were keeping the aging rooms at the exact same 22 degrees Celsius, yet the holes were dying out. The scientists at Agroscope, a Swiss government agricultural research center, decided to investigate. They spent years looking at the bacteria, the fat content of the milk, and the temperature of the cellars. Everything seemed normal. But then they noticed a pattern. The disappearing holes coincided perfectly with a major technological shift in the dairy industry. For centuries, cows were milked by hand in open barns. The milk would go into open buckets. This was the traditional way. But starting in the late 20th century, farms shifted to fully automated closed milking systems. These machines use vacuum seals and stainless steel pipes to transport milk directly from the cow to a refrigerated tank. It is much cleaner, it is much more efficient, it is also much more sterile, and that is where the problem started. The researchers realized that the bacteria were not the only things needed to make a hole. Think about how a rain cloud works. You can have all the moisture in the air you want, but you will not get a raindrop unless there is a tiny speck of dust for the water to cling to. Scientists call this a nucleation point. It turns out those P bacteria need a nucleation point to start a bubble. They cannot just create a hole out of thin air or thin cheese. In the old days, when cows were milked in barns, tiny microscopic particles of hay dust would fall into the milk buckets. These specks of hay were the secret ingredient.
When the cheese was pressed into wheels, those tiny hay particles were trapped inside the curd. As the P bacteria started burping out carbon dioxide, the gas would rush to those hay particles. The microscopic gaps around the dust provided the perfect place for the gas to collect and expand. Without those tiny specks of hay, the gas would stay dissolved in the moisture of the cheese, or it would leak out through microscopic cracks. No hay dust, no holes. To prove this, the researchers at Agroscope conducted an experiment. They took ultra-clean, modern milk and added varying amounts of hay dust to it. They found that they could literally dial in the number of holes they wanted. If they added a lot of dust, they got a cheese with thousands of tiny holes. If they added just a little bit, they got the classic Swiss cheese look with a few large, beautiful eyes. If they added no dust, the cheese remained blind.
This discovery was a massive shock to the food world. It meant that for 100 years, we had been attributing the holes entirely to biology, when it was actually a combination of biology and, well, barn floor debris. It also explains why Swiss cheese made in the winter used to have more holes than cheese made in the summer. In the winter, the cows were kept inside and fed dried hay, leading to more dust in the barn. In the summer, they were out on the grass, and the milk was cleaner.
So, how do they make it today? Well, now that we know the secret, the process is incredibly controlled. Large-scale producers do not just sweep the barn floor and throw it in the vat. They use a refined, sterilized hay powder. They can measure exactly how many milligrams of hay dust go into a 1,000-gallon vat of milk. This allows them to guarantee that every single wheel of cheese has the perfect number of holes, every single time. It is a strange irony. We had to make our milk dirty again to make it look the way consumers expect.
But the holes are not just for looks. They actually tell you a lot about the flavor of the cheese. The P bacteria that create the gas also create the signature flavor of Swiss cheese. They produce propionic acid and acetic acid, which give the cheese its sweet, nutty, and slightly sharp taste. If you have a piece of Swiss cheese with no holes, it usually means the P bacteria did not do their job, and the flavor will be flat and boring.
However, there is such a thing as too much of a good thing. If the holes get too big, it is a sign of a late blower fermentation. This happens if the cheese stays in the warm room for too long, or if the bacteria are too active. The holes can become so large that they merge together, creating huge internal caverns. This ruins the structure of the cheese and makes it impossible to slice. In the United States, the Department of Agriculture actually has strict regulations on hole size. For grade A Swiss cheese, the holes must be between 3/8 of an inch and 13/16 of an inch in diameter. If they are too big, it is grade B. If they are too small, it is grade C.
The aging process itself is a delicate dance. After the cheese is made and pressed, it is soaked in a salt brine for 2 days to form a rind. Then it goes into a cold cellar for a few weeks to stabilize. But the real magic happens when it is moved to the warm room, which is kept at exactly 22 degrees Celsius, or about 72 degrees Fahrenheit. This is the Goldilocks temperature for the P bacteria. They wake up and start eating that lactic acid like crazy. For about 4 to 8 weeks, the cheese sits in this warm room, slowly inflating. The cheesemakers have to tap on the wheels with a small wooden hammer and listen to the sound to tell how the holes are developing. A dull thud means no holes. A hollow musical ring means the eyes are opening up perfectly. Once the holes reach the perfect size, the cheese is moved back into a cold room, around 4 degrees Celsius. This shocks the bacteria and makes them go dormant. It stops the gas production and sets the holes so they do not grow any larger. This cold aging can last anywhere from 4 months to over a year. The longer it ages, the stronger and more complex the flavor becomes.
So the next time you are making a ham and Swiss sandwich, take a second to look at those holes. You are looking at the result of a microscopic interaction between specialized bacteria and tiny specks of hay dust. It took us nearly a century to realize that the secret to the world's most famous cheese was not just about the science of the laboratory, but the beautiful, dusty reality of the farm. It is a reminder that sometimes, in our quest for perfect cleanliness and modern efficiency, we accidentally remove the very things that make our food special in the first place.